Hi viewers, welcome to all. Here we are discussing about a project, a pipeline reduced complexity two-stage parallel LMS structure for adaptive beamforming. Okay, so here in this research we offer a pipeline hardware implementation software reduced complexity of two-stage parallel least mean square adaptive beamforming algorithm. Okay, the parallel least mean square, that is a PLMS, has been further condensed by removing the second independent set of weight, and it's providing in a parallel LMS architectures with less complexity. This proposed approach with the delay and some relaxations approach to get a pipeline hardware architectures for reduced complexity parallel LMS algorithms. It's also called as a DRC-pLMS. Okay, the recommended designs delivers a maximum operating frequency and it take maximum resource utilizations according to synthesis and implementation results. Okay, the proposed effort of this work to remodify the DRC-pLMS architectures with a 2-4-bit input level to increases the efficiency with the weight update model. Finally, this work was developed in Verilog HDL and synthesized in Xilinx Vertex 5 FPGA and compared all the parameters in terms of area, delay and power. Now we can verify the base paper. So this base paper, okay, they are fully designed for the parallel LMS structure to reduce the complexity and increases the efficiency in the adaptive beamforming. Okay, so here, so this is the abstract for this paper. Okay, and here they are given as a basic architectures of parallel LMS structures. Okay, given in figure 3. Okay, so here you can check the architectures. Okay, the LMS will be connected in a parallel way. Okay, LMS 1 and LMS 2. Okay, so this two LMS architectures, okay, we are given the same input. Okay, that is a desired signal, another one is a XK, that is a noise signal. Okay, from as a ULA antenna. Okay, so here we are choose the proposed approach is 5G input sequence. Okay, it recorded from the 5G input scenario. Okay, that 5G input signal we are given into this desired signals under the XK value. Okay, and this architectures will be modified, and the proposed architectures given in figure 5. Okay, so this is a 8 input DRC-pLMS beamformer architecture. Okay, so here you can check. Okay, they are not used as a parallel architectures. Okay, so here the parallel way they are connected as a linear combiner and input weight update. Okay, so here the 8 input linear combiners and 8 input weight update model. Okay, inside of the architectures you can check 2 4 input linear combiner and 2 4 input weight update model. Okay, with some algorithms and delay and add sub. Okay, so as per the architectures we have developed a Verilog logic code. Okay, so here the input part will given here. Okay, DK and XK. Okay, so here this is a DK means it's a desired signal and XK means it's a noise signal. Okay, so this input signals we are given here. Okay, and that signals will come with the this is a subtraction model. Okay, so this DK minus 1 means it's a previous input with the current input. Okay, and this is a D flip-flop. Okay, and this is a add sub block. Okay, and this is a add sub block, and this is a D flip-flop, and this is a conjunction model. Okay, the final output of the conjunctions given to the feedback of the input weight update. Okay, so this internal architectures of this DRC-pLMS beamformer. Okay, the internal architectures will given here. Okay, so that is a figure 6 DRC-pLMS 4 input linear combiner and DRC-pLMS 4 input weight update. Okay, so these two architectures will design related to the FIR filter. Okay, so here FIR filter means it's having a multipliers, adders and delay. Okay, the same multipliers, adders and delay, okay, will occur here. Okay, so this is a multipliers and delay, okay, and adder. Okay, so this is called as a filter order. Okay, the same filter order will be constructed here. Okay, but the coefficients of the multiplications will generated automatically. That is the only difference between the FIR filters and this LMS adaptive filters. Okay, so here this architectures will developed in Verilog HDL. Okay, it's designed as the same 8-bit input. Okay, so here you can check the top model. Okay, so here input signals directly given to the register 8, okay, and output of this register x1 to x8 given to the input 8 linear combiner, okay, and output of this input 8 linear combiner given to the conjunction model, and also for input 8 weight update model, okay. So this architecture is developed as a input 8 model, okay, and we have all the codings, okay, but in the video file we can't possible to show all the codes in open source, okay. And next we can show the simulation results of this project, okay. So here you can check the desired signal and input signal of this work, okay. So this is a 5G input signal, okay, and this error signal is the output of the filters, okay. Next we can check the synthesis results of this work, okay. This project was synthesized in Vertex 5 FPGA. Here you can check the design summary, okay. So number of slice registers, number of slice LUTs, and number of occupied slices, number of IO bonded, okay. And you can check synthesis report, okay. So here delay we can measure, okay, 1.602 nanoseconds, okay. And in the RTL schematic we can check the overall architectures, okay. So here you can check the input signal, okay. So it will be stored into the registers, okay, and register output given to the input linear controller, okay. It will have two 4 input linear combiner. So inside of this linear combiner it will have as a multiplier, adder, subtractor, okay, and conjunction registers, okay, everything occur. And input of the weight, and it will have two 4 input weight update, okay. So inside of this weight update, okay, as per the best paper the architectures will have developed it, okay. So this is a multiplier, add, sub, okay, everything, okay, occur, okay. And the final results of comparisons will update it in the comparisons document, okay. Here you can check the comparisons: DRC-pLMS beamformer, 8 input linear combiner, 8 input weight update, okay. All the comparisons will be updated, okay. And this is a comparisons analysis chart, okay. And final report will shown here: title, base paper abstract, enhancement of the project, proposed title, proposed abstract, exit system, okay, disadvantages, proposed system, okay, advantages, and related notes, okay. Finally literature survey and references. Thank you.
If you need more video related to VLSI project, please like and subscribe this channel.